Hello, today we're going to be talking about the dot product. So the dot product is going to be a vector operation, and this vector operation is represented by a dot in the equation, hence the name dot product. And it can be performed on any two vectors that have equal length. So these can be x and y vectors with just two components, or x, y, and z vectors with three components, so long as those components match. So as long as we have the same number of components in each vector. So the result of the dot product is going to be a single scalar value. So it's going to have a magnitude but not really a direction. This is different from the cross product, which will give us a third vector. And the dot products can be particularly useful for us when we're doing moment calculations about a specific axis. So if we have a specific axis that we're taking the moment about, the moment is going to be equal to u, which is the vector in the direction of the axis we're looking at, times r cross f. And you can learn more about that on the moment of a force about an axis page in the adaptive map textbook. But in here we have this dot product, which is going to be important we know how to do that to do this calculation. Alright, so with the dot product, say we've got a and b, so vector a, vector b, the magnitude of the dot product is going to be equal to a times the magnitude of a times the magnitude of b times the cosine of the angle between the two. So if the magnitude of b is equal to 1, so this vector down here is a length of 1, it's a unit vector, then c, our kind of our dot product here, is going to simply be equal to a times the cosine of theta, and that is going to be basically the component of vector a in the direction of b. It's going to form a right triangle here, and it's going to basically be, if I did this as the x-axis, it'd be the x component. If b was the y-axis, it'd be the y component, and so on. So it's finding the component when we've got that second vector as a unit vector there. Alright, so if the angle between the two vectors is not known, we do have an alternative way of solving for this. So the equation we can use, a dot b, the dot product of a and b, is going to be the x component of a times the x component of b, plus the x component of y, or y component of a times the y component of b, plus the y component or z component of a times the z component of b, and so on, however many kind of pieces we have to this whole thing. And we take that product of x times x, y times y, and we're going to add all those numbers up into one single value for our dot product. So this value can be calculated by hand. There's also kind of computer tools out there that can solve this. We can use something like MATLAB to do a dot product, or we can also use something online like Wolfram Alpha to do the dot product calculation as well. So with that, that's all I have. Thank you for watching, and I hope to see you again.